y'all. So today we are going to start talking about how to solve quadratics. It's important that you know what a quadratic is. We've mentioned this before, but the graph of a quadratic is going to look like a parabola. So if you look at this graph on this first slide, this is considered to be a parabola. And we've actually been doing quadratics. When y'all factor, y'all are factoring quadratic functions. Sometimes it might have something to the third power, but most of the problems y'all are factoring are starting with the x squareds. That means it is quadratic. So it's important for you to know why we factor. The reason we factor is that so we can ultimately find solutions. Okay, so there's different words for solutions. We've actually heard these words before, and we've talked about solutions before. Because when we did lines, we talked about that if you had a straight line, wherever it crossed the x-axis, that was considered to be a solution. There were other words for those. You will need to know these other words. It will be on the test, and I'll keep reminding you of these words, but make sure you know them. So the first word, other than solution, is going to be roots. Okay, so these, wherever it crosses the x-axis, that can also be called a root. It can also be called a zero. You'll see why that is today. And then they're also known as x-intercepts. That's probably the one that makes the most sense. So if you look at this quadratic over here, if you look at this quadratic, you can see that this quadratic crosses the x-axis at two places. Okay, that's why when we're factoring problems, a lot of the times we get two factors. We may get like x plus 3 and x minus 2 or something. So in that case, we have two factors, and we are going to end up using those factors to get the solutions. Okay, and we'll look at how to do that here in a minute. So an important question, we've talked about this a lot this year, but what is the value of y at these solutions? Okay, so if I look here, let's say this one on the right is at 2. Well, what is the ordered pair there? What is the y value? That would be 2, 0. Okay, let's say this one on the left is at -2. What's the ordered pair there? That ordered pair would be -2, 0. So the y value at these solutions is 0, which is why we are going to also call these zeros. Okay, so we're going to get into how to find these today. There's a bunch of different ways to find them. We're going to see that we can factor. We're going to see that we can do the quadratic formula. We're going to see that we can do something called completing the square. And we'll do all three of those ways this part of the unit. And then in the next half of this unit, I'll show you how to also do these in the calculator. But if you know how to factor, this should be pretty easy for you today. All right, so here's kind of the steps that we're going to go through with the factoring. Now, the trick here on all of these problems is that we're going to have them set to 0. Before we do any solving, before we do any factoring, we have to get it equal to 0. Okay, this problem right here, this first one that says x minus 5x plus 4, this is actually one of the more trickier ones on the test, even though it's really the easiest. Notice that this is already equal to 0. Okay, so that's a good thing. So before, we didn't even have any equal signs when we were factoring. Now we are going to have equal signs because we're actually finding solutions, not just factors, but we're finding solutions. Okay, so what we need to do is once it is factored, we need to set each one of those factors equal to 0. If you notice this, you don't see any x squareds. This has actually already been factored for you. So you don't even have to factor it. It's already been factored. So what we are now going to do, since it is factored and it is already equal to 0, we're actually going to take each one of these factors and set it equal to 0. Okay, so here's what we're going to do. You're going to have x minus 5 equals 0, and you're going to have x plus 4 equals 0. And we're just going to solve both of these for x. So on the x minus 5, I would just add 5 to both sides, and x would equal 5. And on this other equation, I would subtract 4. So x would equal negative 4. So let me just talk again about what this means. If I were to draw a quick graph, which you're not going to have to do right here, but I'm just going to show you what this means. If I had a point over here at 5, and I also have a solution over here at negative 4, this graph is going to look something like that. That is where your parabola is going to cross the x-axis. Those are going to be your solutions. All right, so let's go over here to number 2. So remember, before you even start to factor, it has to be equal to 0, okay? This one is, so we can start to factor this. Remember, the first step of factoring is to find your GCF. So here I can see that 2 goes into all these numbers. So I'm going to take that 2 out. That leaves me with x squared minus x minus 2 equals 0. And now I'm going to actually factor this, okay? That 2 that we took out, that's going to be part of our factors at the end, so I'm just going to leave that there. Now we're going to start factoring this. So I'm going to do a times c. So what factors to be negative 2 and adds to be negative 1? Okay, just to save time, I'm going to give you all of these. So this is negative 2 and 1. Those are going to be the factors that we use. All right, so I'm going to break my middle term apart into a minus 2x and a plus 1x. Bring my x squared down, bring my minus 2 down. Now if you want to just pause this and factor it yourself, then do that, or do it with me either way. So this first group, I'm going to take an x out. If I take that x out, that leaves me with x minus 2. The second group, I can only bring a 1 out, and that leaves me with x minus 2. So you see our two factors here, our two groups are the same. So that's one of my factors is x minus 2. And then my other one comes from what's left, which is x plus 1. Okay, so that's half the battle. That's what y'all just did on the last test. Now we actually have to find the solutions. Okay, now this 2 over here, that is a factor. So technically I do need to still set that equal to 0. But does 2 equal 0? No, that doesn't make any sense. So that is not going to be a solution. It is a factor, but it is not a solution. Now I'm going to take x minus 2 and set it equal to 0. I'm going to go ahead and solve that. So I'm going to add 2 to both sides. So x is equal to 2. So that's one solution. Now I'm going to take that x plus 1 and set it equal to 0. I'm going to subtract 1 from both sides. So my other solution is x equals negative 1. Again, remember a solution is an x-intercept. So if I were to graph this problem, this equation, that is where it would cross the x-axis at negative 1 and 2. All right, so here we go. So this says the equation must be set equal to 0. Okay, so we need to get this all equal to 0 before we do any factoring. So looking at A, notice it is already set equal to 0. Okay, the next step is I'm going to start factoring this. So I need to look for a GCF first. All right, well I see they both have 3 and x in common here. So I'm going to take 3x out. That leaves me with x plus 5, and that's equal to 0. So what I need to do is now check to see, am I done factoring? Okay, well do we see any x squareds left? No, we don't. Then we're done factoring. Okay, so I have my two factors. Don't forget about that 3x out front. That is a factor, and x plus 5 is also a factor. So now to find the solutions, we're going to take each one of those and set them equal to 0. So I'm going to have 3x equals 0, and I'm going to have x plus 5 equals 0. Okay, so to solve for x here, I'm going to divide by 3. Okay, well 0 divided by 3 is 0. So there's one solution. Over here, I'm going to subtract 5. So x equals negative 5. So that is where this graph would cross the x-axis, is at negative 5 and 0. Okay, some of you may be thinking, well, why in this case did we set this 3x equal to 0, but on the slide before, when I did the 2, why did that not work? Okay, well notice that the 2 doesn't have an x on it. It was just 2. Okay, and 2 does not equal 0. In this case, I am trying to find x. So 3x equals 0, divide by 3, x is 0. All right, let's go over here to this next one. So first step is I have to get this equal to 0. I'm not going to start doing anything until I do that. So if I need to get this 24b to the other side, I'm going to subtract it. So I'm just subtracting this 24b just to move it over. So that gives me 9b squared minus 24b equals 0. Now I'm just going to factor this like normal. So I need to look and see, do we have a GCF? And we do. So 3b goes into both of these. So I'm going to take that 3b out and I'm going to write what's left. So I would be left with 3b minus 8. And that's all still equal to 0. Okay, notice I don't have any squareds left, so I'm done factoring. I just need to now find my solutions. So I'm going to have 3b equals 0. I'm going to divide by 3. So b equals 0. Okay, that's one of my solutions. Now I'm going to do 3b minus 8 equals 0. Okay, now when you get to some of these that you think you can do them in your head, be careful because this one's going to end up being a fraction. And what I see a lot of the time, y'all try to do it in your head and you end up getting the fractions backwards. So make sure you're still showing plus 8. So you have 3b equals 8. Divide by 3. So b is 8 over 3. Okay, I know that looks funny, but remember 8 over 3, that's just a number. So if I were to type that in my calculator, 8 divided by 3, that's just saying this parabola is crossing the x-axis at about 2.66. Okay, we just want to leave it as 8 over 3 because that's a nicer number. Okay, I'm going to skip these 3 practice problems. Just if you need more practice, you need to come back and watch the ones we've already done. All right, so now we're going to talk about a little bit something different that gets messed up a lot. So I wanted to add it in. This is talking about solving with square roots. Okay, there's a couple different ways to do these. So I want to show you both ways so you have a couple of options. Okay, but here's what happens on something like number 1. A lot of you try to just divide by 4 right now and solve this normally, and that's fine. But here in a minute, I'm going to show you what ends up happening. Okay, but let's work these the same way that we've worked these other ones so far, how we would factor. Okay, the first step is we would need to get this equal to 0. So I'm going to subtract 400, and I left enough space on this slide because we're going to work this 2 different ways. So I have 4x squared minus 400 equals 0. Okay, so I have it equal to 0. Now I just need to factor this. So I'm looking for a GCF. Okay, well they both have 4 in common, so I can factor that out. So I have 4, and then x squared minus 100 now. Notice we still have an x squared, so we are not done factoring this. We still need to see if this can be factored more. All right, thinking back to the last test, if you were left with a binomial, that meant it was probably going to be a difference of squares. And this is a difference of squares. So I can factor x squared minus 100. I can factor that into x plus 10 and x minus 10. And I still have that 4 that I took out, and this is all still equal to 0. Okay? So if you can't remember how to do the difference of squares, you need to go back and look at it because I don't have time to reteach that. But x squared minus 100 is a difference of squares. Now I need to take I actually have 3 factors here. I need to set them all equal to 0. All right, well if I set 4 equal to 0, notice I don't have an x, so this isn't going to be a solution. All right, so I'm done with that. Now I have x plus 10 equals 0, and I have x minus 10 equals 0. So on this first one, now these you could probably do in your head. You know you're going to have one of each here. So I have x equals negative 10 as one solution. And then over here I'm going to add 10. And that gives me x equals 10. So if this were a parabola, if I actually graphed this, it's going to cross my x-axis at negative 10 and 10. All right, so that's one way to do it if you can remember a difference of squares. Notice we have solutions of negative 10 and 10. You will get 2 solutions on most of these. All right, so I'm going to show you the other way. And you can do this other way if you think you're not going to mess it up. All right, so let's say I have this 4x squared. So if you need to rewrite that, maybe over here where you have some room, then you can do that. 4x squared equals 400. Let's say I was just to solve this like normal, like a normal problem. Okay, well, how would you get the 4 off of the x squared? All right, we would divide. So divide by 4. That leaves me with x squared equals 100. Okay, well, how do you undo something that is squared? You take the square root. So here's what ends up happening here. Okay, well, the square root of x squared, that leaves me with x. Most of you would be able to tell me that the square root of 100 is 10. But what else is the square root of 100? What times itself also gets you 100? Also, negative 10. Because negative 10 times negative 10 is also 100. So what ends up happening, if you solve it this way, what I see a lot of times is a lot of you will get 10 as a solution, but you'll forget you can also have negative 10. So I don't care which way you work it, but you need to get the right answer. Okay, we'll see an example of that on number 2. All right, so let's work the factoring way first. Okay, if I'm factoring this, it's already equal to 0. Okay, and I think 5 goes into both of these numbers. So I'm going to take a 5 out. That leaves me with x squared minus 36. Okay, notice inside we're left with a binomial, which means it's probably a difference of squares, and it is. So I'm still going to have that 5, but if I factor this, that's going to get me x plus 6 and x minus 6. Again, if you don't completely understand the difference of squares, you need to go back and look at that. All right, so I'm going to take 5 and set it equal to 0, because that's one of my factors. Okay, well, there is no x, so that doesn't make sense. So that's not a solution. Now I'm going to take x plus 6 and set it equal to 0. So if I subtract 6 from both sides, that's negative 6. And then I'm going to take x minus 6 and set it equal to 0. Add 6 to both sides, so x is 6. So that's the factoring way. Now let me show you what you could do if you solved this the other way. So I have 5x squared equals, if I add this 180 to both sides, it's going to equal 180. And then I'm going to solve this. I'm going to divide both sides by 5. That gets me x squared equals 36. Now how do you undo a square? You take the square root. So the square root of 36 is not only 6, but it is also negative 6. Which is what we got when we factored it, but you cannot forget your negative answer on those. Okay, we are going to skip number 1 here, and we're going to skip number 2. Although on number 2, just notice it says equal to y. Okay, just assume that also just means equal to 0. That one would be ready to be factored, so you would have to factor it and then set each factor equal to 0. The only thing we are adding in today is having to set these equal to 0. Okay, but we are also adding in a little bit of word problems. All right, number 1, the sum of a number and its square is 12. What is the number? Okay, so we're trying to find these numbers. The sum of a number and its square is 12. So I'm going to call this number that we don't know, I'm going to call it x. All right, so we have the sum of our number, which is x, and its square. Okay, well, what square? It is x. So its square, that would be x squared, is, what does is mean? That means equals 12. So we have the sum, which means add, of a number and its square. Okay, I'm going to go ahead and put this in what I know to be the right order. We need our x squared first. So this is going to be the sum. So x squared plus x is 12. So equals 12. Okay, and we need to find the number, which means we need to find x. I cannot start factoring this until it is equal to 0. So I need to subtract this 12 and move it over. So this is x squared plus x minus 12 equals 0. Okay, I'm going to shortcut a little bit of this. I'm just going to tell you here we would need factors that multiply to be negative 12 and add to be 1. Those factors are going to be negative 3 and 4. So I'm going to go ahead and tell you that if we factor this, it is going to be x minus 3 and x plus 4. Okay, just to save some time. All right, now I need to take one of those or both of those and set them equal to 0. So I have x minus 3 equals 0 and x plus 4 equals 0. So in this first one, I'm going to add 3 to both sides. So that gets me x equals 3. Over here, I'm going to subtract 4. And that gets me x equals negative 4. All right, moving on to the next one. So I may, just to save some time on these, I may get them set up, but I may not solve them all the way through, so this video is not as long. All right, number 2, if the sum of a number and 5 is less than the square of the number is 1, what is the number? So the sum, so that's adding, of a number, we don't know that number. So the sum of a number and 5 less than, okay, less than, that does not mean the less than sign, that means subtracted from the square of the number. All right, so that's going to be x squared is, always find where that is located, because that's going to be your equal sign, and that's the easy part, is 1. What is the number? All right, so here we go. I need the sum again. I'm going to start out with my x squared here. So I have the sum of a number and 5 less than that. So I need 5 less than the square. So that's going to be minus 5. And I still have the sum, so that's plus x, is 1. All right, now notice something a little messed up about this equation. It's not in the right order. Notice you have your x squared, you have your number, and then your x. We need that x to be in the middle. So we can move this around. We're going to have to move our 1 over to the other side anyways. So I'm going to subtract 1. So I'll subtract that from my 5 because I need to get this equal to 0 first. When I rewrite this, I'm going to write it in the correct order. So it's going to be x squared plus x, and then negative 5 minus 1 is minus 6. If this were to be factored, our factors would end up being x plus 3 and x minus 2. So if I were to take each one of those and set them equal to 0 from this first factor, x would be negative 3, and the second factor, x would be 2 after I solve. Okay, if you're having trouble grasping that, take these both and set them equal to 0 and actually solve them out. I'm just trying to save some time. Number 3, we've got the length. The length of a rectangle is 2 times the width. All right, anytime on these you see anything about a shape, we need to draw it. It's going to make a lot more sense. So it says the length of a rectangle is 2 times its width. All right, we don't know the width, so we're going to call the width W, and the length is 2 times that, so the length is going to be 2W. The area of the rectangle is 72, all right? So the whole area is 72. Find the dimensions of the rectangle. So what you have to know is how to get area. All right, well, area is length times width. So our area here is going to be W times 2W, and that's going to equal the area that is 72. So these are problems. You're going to have to work these out because this isn't equal to 0 yet. So I can't just take each one of these factors, these sides, and set them equal to 0. That's not going to make sense. So what I have to do is work the left side out, and then I'm going to have to move my 72 over. So W times 2W, that's 2W squared equals 72. Now this is one of those problems that could be solved by taking the square root. You just have to be careful that you're getting both answers. Okay? Or you move the 72 over, you take your GCF out, and you do the difference of squares. Okay? To me, it's easier just to go ahead and solve this. Because of the way it's set up. Notice I don't just have a W, okay? So I don't have to factor this like doing A times C adds up to B because I don't have all the parts. So I could just divide by 2 here. That gets me W squared equals 36. And then to remove that square, I can take the square root. You just have to remember that not only is the square root of 36 6, but it's also negative 6. Okay, so we need to make sure here that we're answering the question. It says to find the dimensions of the rectangle, all right? I just got two possible values for W. Okay, so could W be 6? Yeah, that makes sense. Could W be negative 6? No, that doesn't make sense because dimensions cannot be negative. So in this case, I'm just going to go with my positive answer. This is only because we're talking about dimensions. On the two problems before, negative answers were okay, but they're not okay here. All right, so if I want to find my width, which is just W, my width would be 6. And then how do we find length? It said the length is 2 times W, which means that would be 2 times 6, which would be 12. You're going to see on your homework, it's going to give you a set of steps. Okay, what you would want to do in this case now is just plug these in and check your answer. So if I have 6 and 12 as my two sides, okay, well what is 6 times 12? It's 72. So the only thing that's different on these is you're actually having to set up the problem and then work it out. Okay, number 4, the length of a rectangular garden is 4 yards more than its width. The area of the garden is 60 yards. Find the dimensions of the garden. All right, so we've got another shape. It says the length is 4 yards more than the width. So that's going to be W plus 4, and then this other side is W. It says the area of the garden is 60 square yards. Find the dimensions. All right, again, we've got length times width here. So it's W times W plus 4, and that area is equal to 60. Okay, again, we're going to have to get this equal to 0, which means I have to work out this left side first. So I'm going to distribute that W. So W times W is W squared. W times 4 is 4W, and I have still equal to 60. Before I can factor this, I have to get it equal to 0. So I'm going to move the 60 over. So I have W squared plus 4W minus 60 equals 0. Okay, then what you would do is you would factor and then set factors equal to 0 and find your sides. Okay, so I'm not going to go through the rest of that. Number 5, the width of a rectangle is 16 inches less than the length. All right, so we have a rectangle again, 16 inches less than its length. All right, so I'm going to say the width is this side right here, and it is 16 less than the length. I don't know the length, so I'm going to say that's L minus 16, and my length is just L. Okay, and we're talking about area here again, so I'm going to have length times width. So I've got L times L minus 16 is equal to 80. Distribute that L, so it's going to be L squared minus 16L equals 80. If you already know that 80 needs to come over right there, and you just want to go ahead and put minus 80 at the end of that, you can do that. You're probably going to get good enough to do that. But I do need to subtract that 80 and move it over. So I've got L squared minus 16L minus 80 equals 0. And then I would factor and set those factors equal to 0 to find my dimensions. Okay, but I'm just going to stop there on that one. Okay, last two here. The perimeter of a rectangle is 220. So notice here I'm talking about perimeter now. So I've got this rectangle and the perimeter is 220. If the width is W and the length is W squared, determine the rectangle's length. All right, so it's saying the width is W and the length is W squared. So now we have to figure out how do we get perimeter. This is different than the area problem. Perimeter is add up all the sides. Okay, so I have W squared plus W squared. That's 1W squared plus 1W squared. That gets me 2W squared. And then I have W plus W, that's 2W, and that is equal to the perimeter, which is 220. So I would move the 220 over, so I got to get it equal to 0. So I have 2W squared plus 2W minus 220. And then on this one, if I were to keep working this out, there is a GCF, so you would have to take that out first. Then you would factor, then you would find the solution by setting them equal to 0. Okay, the hardest part of these though is setting them up. Y'all should all know how to factor by now, so I'm not as worried about teaching that to you right now. Okay, but you will do that on your homework. Number 7, a billboard is 50 feet longer than it is high. So I've got this billboard. It's 50 feet longer than it is high. I don't know what the height is. If you read this whole thing, it's not going to tell us the height. So I'm going to say that the height is h, and the length is going to be 50 feet longer than it is high. So it's going to be h plus 50. Okay, and it's saying that it's 336 square feet, which means that is the area. So how do we get area? We do length times width. So I've got h times h plus 50 is equal to 336. Distribute the h. So you have h squared plus 50h. I know that I'm going to have to subtract that 336. So I'm just going to go ahead and put that minus 336. Okay, there is no GCF on this one, so you would then factor, and then you would set those factors equal to 0 to find your solutions. I know this is a long video, but I just wanted to make sure you had an example like everything that is going to be on your homework. So make sure you work on all of those, and I want you factoring through all of these and finding the solutions for all of these as part of your homework.